Can you believe this is the last section of the year? But it's one of the best sections, so we're gonna go out with a bang. This is 12.5, probabilities of combinations. There are two formulas. I would push pause, write them down, and get your calculator and get your book. Permutations, P for permutation, C for combination. There are more permutations than there are combinations. ABC, CBA, BAC are different in a permutation. ABC, BCA, ACB, etc. Those are all different in a permutation. And remember, there's that false advertising. It's a permutation lock. So there are a lot of locker permutations, okay? It's not a combination. There are fewer combinations. ABC, BCA, ACB, blah, blah. Those are all the same. Those are all the same. Okay, so example of a permutation to help you remember is winning a race, right? Whether you're going to be the gold medalist, the silver medalist, the bronze medalist, those orders matter. For a combination, it's like when you're working in a group. So you had to do that project last week. When you work with a group, does it matter if the group is, Brandon, Jason, and Brian? That's the same as Brian, Jason, and Brandon. Okay, so groups, combination, nor order. Salad. The order in which you put the ingredients in the salad doesn't matter. You're gonna shake it all up, you're gonna get the salad. So whether the lettuce goes in first or the tomatoes go in first, doesn't matter. Those are all combinations. Calculator. So I'll do an example of this with variables in a minute. Calculator. If you have the 84, there is a shortcut to get to permutation, combination, and factorials. And that is alpha, window, and I believe it's number 7, 8, and 9 maybe. And if you don't have the 84, totally okay. Everybody's calculator using the generic math menu will get you there. Math, arrow over to probability, and I believe it's numbers 2, 3, 4. And I think this is 7, 8, 9. Okay? So here we go. Let's do an example with some variables. Your calculator can do this for you, so that's just a plug and chug. And of course, if we were in class, I wouldn't be asking you straight plug and chug. I'd ask you to use, binomials, trinomials, etc. This is what I mean. NPR. So your N is N plus 1, and your R is N minus 2. So I want to know, what does this look like? So for a permutation, N, which in this case is N plus 1, N, R, parentheses, over N, which is N plus 1, minus R, which is N minus 2. That says plus 1. So this is N plus 1 factorial over N minus N, which is 0, 1 minus negative 2, 1 minus negative 2, which is 3. Factorial is 6. Okay, let's do the same thing with a combination. So I'm going to do the same problem using a combination instead of a permutation. Okay, this is going to be N, which is N plus 1 factorial, over R, which is N minus 2 factorial, times N minus R, which we just did in the previous problem, but I'll show it again. n plus 1 minus n minus 2. Factorial. Just plugging into the formula. N plus 1 over n minus 2. And then again, we just did n plus 1 minus quantity n minus 2, which was 3, factorial is 6. This can be simplified. This can be simplified. So, which one of these is larger? If you watched 2 videos ago, which one's larger, n plus 1 or n minus 2? N plus 1 is larger. So I'm going to take n plus 1 and I'm going to expand it out, and then hopefully I'll be able to reduce it with the n minus 2 factorial. Always start with the larger. Adding 1 is larger than subtracting 2. So this is going to be n plus 1, n minus 1, n minus 2, n minus 3, blah, 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 but I'm going to stop at n minus 2, bam, over 6. So you are left with n plus 1, n minus 1, all over 6. Okay, boring. Let's get into the good stuff. Let's get into the good word problems, and they're fun word problems, I promise. Here we go. Page 660, if you have your book, that's super helpful because I don't want to have to write it all out. My board is too small. Page 660, let us look at, let's look at number 32. 32. So we're talking about probability. So probability, the number of ways the event that I want, the number of ways the event that I want over the total number of ways the event can happen. So the results I want over the possible results. Okay? Here we go. Sorry, I have a small little table over here and it's hard to keep all the markers and keep my calculator and keep my book, so I'm trying. So 32. Okay, so it says the varsity croquet team. Do you know what croquet is? Croquet, it's like, oh, it's too hard to explain. You should look it up. It's a pretty fun game. The varsity croquet team, 4 boys, 8 girls, travels to an out-of-town game. Their coach, Mystique, get it, Mystique? I love this book. Will take 7 of them in her station wagon. If they get into cars at random, what is the probability that Mystique's car has 2 boys, 5 girls, all boys, and then Peter Doubt and Manuel Desterity, who are 2 of the boys? Okay, so first thing I'm going to do is figure out how many ways can the kids get in the car, period. Then I'll look at my desired outcomes. So we have 4 boys, 8 girls for a total of 12. So I have 12 kids, and we're going to take 7 of them in the station wagon. Does it matter who gets in first? No. This is a combination. As long as you're in the car, you're getting to go on the field trip or whatever it is they're going. So, step 1. Even though it doesn't ask me this, you need to figure out how many ways can the kids get in the car. There are 12 kids. Combination, because order doesn't matter. And I want 7. Okay? So find your calculator. Can you hear me crashing everything off to the side? Okay, what are we doing? 12, alpha window, C7, 792. There are 792 ways that 7 kids can go on the field trip or the tournament or whatever it is they're doing. Okay, I want 2 boys, 7 girls. This is the star. This is where almost all probability problems fall into this format, I should say. Two boys and 5 girls. Okay, 2 boys. How many boys are there to choose from? There are 4 boys to choose from. So the number of ways to get 2 boys. 4 boys, choose 2. There are 4 boys, I'm going to choose 2 of them. The remaining kids need to be girls. And, previous video, and multiply. And, times. The rest need to be girls. So how many girls are there? There are 8 girls. I want to choose 5 of them. This is critical. Four plus 8 is 12. There are 12 total kids to choose from. 2 plus 5 is 7. This is how many are going to be going on the trip. Notice 12C7. That adds up to 12C7. Okie dokie. So let's plug into our calculator. Okay, so 4C2, alpha window, number 8, 4C2. This is 6, 4C2 is 6, and 8C5, alpha window 8, 8C5 is 56. So there are 6 times 56. There are 336 ways that 2 boys and 5 girls are going to be going on this trip. I don't know what the question asks, but I'm going to take it a step further. What is the probability that 2 boys and 5 girls go on this trip? How many ways can 2 boys and 5 girls happen? 336. How many ways can 7 different kids get in the car, the station wagon, whatever it is? 42.4. There is a 42.4% chance that when these kids get in Mystique's car, there's a 42.4% chance that that car is going to have 2 boys and 5 girls. This is critical. When we start doing problems in a minute with decks of cards, you'll see why. All boys, all girls. Okay. All boys or all girls? Seven kids are going, correct? What's the probability that it's all boys? It can't be all boys. There's only 4 boys to choose from when you're taking a car of 7 people. It's impossible. The probability that it's all boys is 0. The probability that all of the boys get to go, that's different. Okay, so it can't be all boys. All girls. 8 girls, I want 7 of them to go. Wait a minute, this doesn't add up to the whole, remember it was 12C, what was it? That doesn't add up to 12C7, what just happened? It does. If it's all girls, so this means I want 7 girls and 0 boys. You don't have to show this step, I'm just showing you where the 12C7 is going to come into play. So we have no boys. 4 boys, choose none of them. 8 girls, choose 7. 4 boys, choose none. 8 plus 4 is 12. 7 plus 0 is 7. So the probability, so let's see, 8C7, how many ways? I believe that's 8. I believe that there are 8 different ways that you can choose 7 girls, but let us see. Alpha window. Number 8. 8C7. It is indeed 8. That's 0. No, it's not. This is a little tricky. How many ways can you choose none of the boys? One way. Don't choose any of them. So technically it's 1. So what did I say this was? 8 over 792. So there are 8 ways to choose all girls. The probability of that happening is pretty slim. 1%. You've got about a 1% chance of all the girls randomly getting in, that the car will have all the girls. All girls, not all of the girls. Okay, the next one asks for specific people. The next one asks for specific people, and I did this in the last video. I don't care, like, what's the probability that you choose Portia? What's the probability that you choose Titus? What's the probability that you choose Miss Babiak? What's the probability that you choose Mrs. Reed? 1. Okay, there is 1 person named Mrs. Reed. There is 1 person named Miss Babiak. There is 1 person named Portia, 1 person named Titus. So here we go. I don't know who they ask you, Mystique, or I don't even know who it is. What's the probability that you choose 2 specific boys? So I'm just going to say that you choose 2 specific people. And we're going to say Calvin, who's a boy, and Phoebe, who is a girl. Okay? All right. We're assuming that there's 1 Calvin. So if I want to choose Calvin, that's going to be 1C1. 1 Calvin, I want to choose him. I also want Phoebe, 1C1. There is 1 Phoebe, I want to choose her. 1 Calvin, let's choose him. 1 Phoebe, let's choose her. What about the rest though? This adds up, your N's add up to 2, your R's add up to 2. But we're taking 7 people all together. So if I choose Calvin and I choose Phoebe, how many people are left that I need to choose? There are 5 people left. Oh no, there are 5 people left that I need to choose. This is the remaining people that go in the car. Who am I choosing them from? I don't care if the remaining 5 people are boys or girls. I just care that Calvin and Phoebe are in the car and they get to go. So how many people are there left to choose from? There are 10 people left to choose from. 4 boys, 8 girls. There are 12 people. I think I misspoke. I think I was supposed to say 10, not 12. Sorry. There are 12 people total that I'm gonna choose from. I choose Calvin. That's 1 less person. I choose Phoebe. That's 1 less person. So I have 10 people left to fill up the 5 remaining spots in the car. So the number of ways that I can choose Calvin and Phoebe, 10, alpha window, 8, 10C5. This is 1. This is 1. 10C5 is 252. 1 for Calvin, 1 for Phoebe. There are 252 ways to choose the remaining students over 792. There is a 31.8% chance that Calvin and Phoebe get to go on the field trip. That they randomly get in the car. Okay, let's talk about cards. Previous video, there are hearts, clubs, spades, diamonds. 4 suits, 13 cards per suit, 3 face cards, Jack, Queen, King, and then the ace, which doesn't count as a numerical card and it doesn't count as a face card, it's just the ace. Okay, here we go. Most card games are 5 cards. You are randomly dealt 5 cards. So first, let's just figure out how many different ways can you get 5 cards. Let's just start there. So how many cards are in the deck? That's right, 52. You would think I would know this already from all the times I've done these problems. All right, 52, C5, 52, alpha, window, C5. It's big. Store it for yourself because we're going to use it numerous times throughout the remaining example. So just go ahead and store it. Store alpha A. It is 2,598,000. $960. It doesn't matter which order they come in, right? So when the dealer deals your 5 cards or whatever, and you pick them all up and you look at them, and then if you're me, you sort them by suit and you sort them by number, blah, blah. There are 2,598,960 ways that can happen. Okay. Exactly, at least, are different things. I want to know the probability that you get. I'm sorry, we're going to do 5 cards. 5 cards for the remaining example. What's the probability that you get at least 4 hearts? Probability that you get at least 4 hearts. Okay, so let's write this out. This is the same exact answer for at least 4 clubs, at least 4 spades, at least 4 diamonds. They're exactly the same answer. So if I want at least 4 hearts, that means I want 4 hearts, or I want 5 hearts. I chose hearts because I can draw a heart. I can't draw the other ones. And you know what? Even my hearts aren't so hot. Oh well. Okay, if I have 4 hearts, I don't care what the other card is. But it can't be a heart. So that means I'm going to get 4 hearts, because I'm already going to take care of the 5 hearts over here. So 4 hearts. How many hearts are there? 13. I want 4. The other card is anything but a heart. So how many cards are left that aren't hearts? 39. Notice, 13 plus 39, 52. I have 4 hearts in my hand. I need 1 more card that isn't a heart. Choose one of them. Notice, 13 plus 39, 52. 4 plus 1, 5. Magic. Plus all 5 hearts, there are 13 hearts. How many do I want? Exactly, I want 5. Oh, this is supposed to add up. Remember 13, 39, I have 39 cards to choose from. How many more cards do I want? None. You do not need to write this. I'm showing you so that you can see 13 plus 39 is 52, 5 plus 0 is 5. And then, yeah, 5 plus 0 is 5. Here we go. This would be going so much faster if we were in class because you would be saying all the answers to me. Let's see, 13C4 times 39. This is 27,885 plus 13 alpha window C5. 1,287. All over this big number. Okay, I'm not gonna write it. For me, it's in. I stored it in A. So there we go. 27,885 plus 1,287 equals divided by. Where is it? Alpha A. Not good. 0.35%. You don't even have a 0.5% chance of getting at least 4 hearts. So 4 hearts. Same for spades, same for diamonds, same for clubs. Okay? So in Vegas, this, if you were to get a hand of at least 4 hearts, which means 4 hearts or 5 hearts, which is very difficult to do, this pays big. The less likely, the harder it is to get the hand, the more it pays. So this is how people win big and lose big. So let's do, I don't know, how about exactly 3 hearts and 2 jacks? That is known as a full house. No, it's not. No, it's gotta be, let's just do 3 hearts and 2 jacks. Let's just do 3 hearts and 2 jacks. Okay. This is going to be the same for 3 of one suit, 2 of another suit. The results are going to be the same no matter which suits you choose. So 3 hearts, 2 jacks. Can you hear everything crashing? I'm really sorry. I said something, I think I said it wrong. We're gonna do 3 hearts and 2 spades. I apologize. 3 hearts and 2 jacks is too complicated because what if you get the jack of hearts? So, 3 hearts, 2 spades. 13 hearts. I want 3 of them. 13 hearts, I want 3 of them. 13 spades, I want 2 of them. 13 hearts, I want 3. 13 spades, I want 2. So notice, here's my 5. Push pause, figure out what the remaining, what jiggy is, combination. Okay, if you said 26 C0, you would be correct. There's 26 non-hearts and spades left. I want none of them. Boom. So here we go. The answer to this is 13 alpha window. My calculator's messed up. 13 alpha window number 8, 13C3 times 13 alpha window 8 C2. 22,308. This is the number of ways that combination can happen. What's the probability that you actually get that? Divided by alpha A. Oh, really low. Oh, actually it's higher than the previous example. 0.86%. This is true for any suits. 3 of a suit, 2 of a different suit, 0.86%. Let me see if I can find one good one in the book. And then that will be it. Oh, you have to do number 36 in the homework, which is just like this. Okay, I'm just going to make up one more. What is the probability that your card has 1 8, 1 9, 1 10, 1 jack, 1 queen? How many 8s are there? 4. 4, choose 1. How many 9s are there? 4, choose 1. How many 10s are there? 4, choose 1. How many jacks are there? 4, choose 1. How many queens are there? 4, choose 1. 1, 2, 3, 4. My R's are awesome. My N's are not. 4, 8, 12, 16, 24. There are, I think, 28 other cards left. You don't need to write it in. But if you're wondering, 4, 8, 12, 16, 20, did I? 1, 2, 3, 4, 5. That's 20. So there are 32 cards left. 1, 1. I believe that's 4 to the 5th power, 1024. $1,024 ways that you can get an 8, 9, 10, Jack, Queen in your hand. I think I've done that right. Something tells me I didn't do it right. I don't know why. Let me double check. That's right. Okay, so this is the number of ways you can get 8, 9, 10, Jack, Queen, divided by that huge number, which for me was stored in letter A. Let's see, 1024 divided by slim to none. I mean, this is essentially, is it actually 0? No, but the percentage is so small, I wouldn't be betting any money on it. Okay, so if you have homework questions, post them, but this is it. This is the end. 12-5, permutations, combinations, factorials, etc. Post your questions on Classroom, and hopefully I'll see some of you at office hours. Bye.